So today we're going to be looking at systems of equations. So what is a system of equations? Well, first we need to consider it graphically. A system of equations is two or more lines that are drawn on a coordinate plane like this. So a system of equations, it's most commonly just two lines, and the goal of a system of equations is to find out where they intersect. Okay? Now, there are three types of systems of equations. There is this type that I just showed you, two lines drawn on the plane and they intersect at a single point. Another type of system of equations is where both lines are the exact same line. And by that token, they intersect at every point on the line. They intersect at an infinite number of points. And we're going to see an example of that when we look at them mathematically. Okay? And the final item is when the two lines are exactly parallel to one another, in which case they don't intersect at all. They intersect at 0 points. Okay, let's work through some examples. First and foremost, we have the line 2x plus 3y equals 8, and the line 5x minus 3y equals negative 1. Okay, now we're going to be consulting two methods by which to conduct solving these systems of equations. One method is going to be by elimination. The other method is going to be by substitution. Okay? So we're first going to look at the method of elimination right here. When we use the method of elimination, we're going to look at the variables in our systems of equations, and we are going to consider how we can combine these two equations into one, and in doing so, eliminate one of the variables. So in this case, you can see that in the top equation we have a positive 3y, and in the bottom equation we have a negative 3y. Which means that if I were to take these two equations and add them together, I'd get 2x plus 5x equals 7x, 3y plus negative 3y equals 0, and 8 plus negative 1 is equal to 7. So now this is what I get when I do the elimination. Okay? So I am left with 7x equals 7, and now it is very easy for me to solve for x. X equals 1. Okay? But what's important to consider is I'm not done yet. Okay, I have only found the x-coordinate in my system of equations. I need to take this x-coordinate and I need to plug it back into one of my two equations. Okay, I get 2 times 1, because I plugged in for x, plus 3y equals 8. 2 plus 3y equals 8. If I subtract 2 from both sides, I get 3y equals 6, y equals 2. So now, after plugging in the second time, I have got both the x-coordinate and the y-coordinate of my systems of equations, and I can combine those two down here to get an ordered pair, 1, 2. Now recall from the top that a system of equations is designed to find where the two lines intersect. So this ordered pair that we have right here, the significance of this is the point on the plane where our two graphs intersect, where our two lines intersect. So let's try another problem. This time we're going to look at the substitution method. 2x plus 5y equals 19, and x minus 2y equals negative 4. Okay? So when we do the substitution method, we're going to try and isolate one of the variables. We want to get one variable by itself. And it seems very easy for us to do that for this bottom equation right here. So what I'm going to do is I'm going to add 2y to both sides, and I'm going to be left with x equals negative 4 plus 2y. Or if I want to write it a little bit cleaner, I can write it as x equals 2y minus 4. So now I have x isolated, okay? And now I can take x and I can plug it into this x right here. So let me show you how that is done. It's going to be 2 times x, which is 2y minus 4, plus 5y equals 19. Okay, now let me distribute my 2 inwards, and that's going to leave me with 4y minus 8 plus 5y equals 19. I'm going to combine my y values and get 9y minus 8 equals 19. Now I'm going to add 8 to both sides. 9y equals 27. Therefore, I'm going to divide both sides by 9 and get y equals 3. So now I have 1 point on my ordered pair. I have 1 point where the two intersect. So now I'm going to take my y and I'm going to plug it back into one of my two equations. It's useful to stop for a moment and to think which of these equations would be easier for me to plug into. Let's probably plug it into this one, because this is a valid equation. Okay, I'm going to get x equals 2 times 3 minus 4. X equals 6 minus 4, therefore x equals 2. And now I have the other x coordinate contributing to my ordered pair, and I can write the point of intersection as the point 2, 3. There we go. So now we're going to show an example like 2x plus 2y equals 8, and 2x plus 2y equals 7. Okay? So what I can do right here is I can try and do the elimination method. If I subtract the bottom from the top, I get 2x minus 2x equals 0, 2y minus 2y equals 0, and 8 minus 7 equals 1. Okay? And I'm left with 0 equals 1. Hey, wait a minute. That's not supposed to happen. How do I get 0 equals 1? Well, this is how you know that you are dealing with two lines that never intersect. Because when you tried to solve for the point of intersection, you got a mathematical impossibility. You got something that doesn't make sense. Okay? So to clarify, the only thing that determines for sure that your two lines are absolutely parallel, like this, that the two lines never intersect, is if you have a constant equaling a different constant. Only then do you say the lines are parallel. Okay? So you can write that there is no point of intersection. All right? Now let's consider the example of 2x minus 2y equals 4 and 4x minus 4y equals 8. Okay? Let's do another substitution example just for practice. I think this equation is easier. So first thing I'm going to do is I'm going to add 2y to both sides. I'm going to get 2x equals 4 plus 2y. Then I'm going to divide both sides by 2, and I'm going to get x equals 2 plus y. So now I have something to substitute with. I have one variable by itself. So now I'm going to take this x and I'm going to plug it into the other equation. 4 times 2 plus y, because that's what x equals, minus 4y equals 8. Okay? So that upon distributing the 4, I'm going to get 8 plus 4y minus 4y equals 8. And I'm going to combine like terms here. 4y and negative 4y both cancel out to leave me with 0. So I get 8 equals 8. That is a true statement. One constant equals the exact same constant. That tells me that I am dealing with two of exactly the same line. Okay? This is how I know that I'm dealing with two lines that are exactly on top of each other, like in this example here, the red line and the blue line. So if I get one constant equals a different constant, they're two parallel lines, and one constant equals the same constant gives me two lines that exactly overlap. Okay? That's going to be systems of equation, guys. Aside from that, enjoy life.